So these are the solutions to the quiz, the first quiz that is on vectors and Newton's third law that was taken last week, last Thursday and Friday, 11-4, 11-5. The first question has two students fighting over a textbook. We have Lauren pulling to the left at 300 newtons and Abby pulling at 150 newtons, but at an angle 25 degrees south of east. The first question is to find the x and y components of each force from the students. So Lauren is easy in that she's only pulling in the x direction. It's just the simple straight pull to the left or to the east. So the force of Lauren should be negative 300 newtons in the x direction and 0 in the y. Abby requires a little bit of trig in this situation. She is pulling over like so. I'll call that force of Abby in the x direction. And as she is pulling down, I'll call that force of Abby in the y direction. Using trig, I have an angle that looks like this, where this is 150, this is the x, and this is the y. And this angle here is 25. So that means in the x direction, Abby's force will be 150 newtons times cosine of 25. And in the y direction, it will be 150 newtons sine of 25. Now I need to do a direction check. Abby is pulling to the right, that's positive. She's pulling down towards the south, that should be negative. So Abby's y component needs to be negative. So those are the answers to A. Part B asks us just to find the sum in the x and y direction, so I'm literally going to add up the two columns. So I'm going to add this number and this number. When I do that, I should get 164 newtons, but that's negative. So that means Lauren is pulling harder in the x direction to the left than Abby is pulling in the x direction to the right. I do the same thing in the y side, and it's simply negative 63 newtons. Now, you're asked to then find the force, the net force on the book, and so I now need to put these vectors back together using the Pythagorean theorem. The vector diagram now looks like this. The net force this way, 164 newtons, and down 63 newtons. Now remember that vectors need to be connected head to tail. These vectors are tail to tail. So I need to move one of them, so I'm going to move 63 newtons. I'm now connected correctly, and this is the hypotenuse that I'm looking for. This blue vector will represent the net force. So the net force equals 164 squared plus 63 squared. Take the square root. So the net force is 176 newtons. As I said, I also need to include direction. I chose to find this angle right here. And so that angle will be equal to the inverse tangent of the opposite leg, 63 newtons, over the adjacent leg, 164. And theta equals 21 degrees, and that is south of west. So the final answer would have been 176 newtons at 21 degrees south of west. Moving on, we have the chipmunk problem. Number 2, the chipmunk runs 15 meters north and then 20 meters east. And you had to find the chipmunk's total displacement So the total displacement is this hypotenuse. So delta D equals 15 meters squared plus 20 meters squared. Take the square root. And I end up with 25 meters as the displacement. Again, I need to give direction. This time I chose to give this angle. That angle is the same as this angle up here. So theta equals inverse tan of the opposite leg, 15, over the adjacent leg, 20. And I end up with 37 degrees north of east. So my answer is 25 meters, 37 degrees north of east.